Usually when we talk about fighting massive, like, landscape-destroying forest fires, we instantly picture the exact same things.
We think of the helicopters.
Yeah,
Yeah.
exactly. We think of thousands of gallons of water dropping from helicopters. We think of firefighters in that heat-reflective gear digging those massive trenches in the dirt. It's this very visceral battle of force against force.
Right, it's an elemental fight.
Correct.
We naturally just assume that the only way to beat fire is with water and earth.
Right. But then you look at what's happening right now in Mohang Son province in northern Thailand, and suddenly you realize the most effective tool for putting out these massive, devastating regional fires isn't water at all.
It's actually a plant.
Yeah, it's a plant, and not just any plant, but a historically stigmatized, heavily misunderstood crop that is somehow putting out literal fires and, like, saving an entire region's economy at the exact same time.
It is the absolute definition of a paradigm shift. What we're looking at today is it's really a masterclass in systems thinking.
Okay.
It's taking a step back from a burning forest and realizing the flames are just a symptom of a much deeper disease.
Welcome to this deep dive. For you, the learner, whether you're trying to crack a complex, stubborn problem in your own industry, or you are just insanely curious about how the world works, you are in the exact right place.
You really are.
Today, our mission is to explore a fascinating policy framework study straight out of Mohang Son, or MHS as we'll call it for short. We're going to trace the blueprint for transitioning a whole region away from devastating slash-and-burn agriculture and into a sustainable bioeconomy.
Yeah, and we're going to look at the nuts and bolts of how processing one specific crop, which is industrial hemp, can generate serious ground-up community wealth.
It's amazing.
It really is. But what's crucial to understand before we begin is why this framework matters to you, even if you aren't in agriculture or public policy. Because this study is a perfect example of how to shift from reactive problem solving to proactive, livelihood-centered solutions.
And to understand why a radical, proactive solution like hemp is needed, we have to first understand why the current system in northern Thailand is, well, literally going up in smoke.
Because it's bad.
It's really bad. The study surveyed 200 households across 3 different communities to assess the real-world impacts of what they call FFS, forest fire smoke. And the data they found is pretty alarming.
Very alarming, yeah.
They used something called principal component analysis to sort through the survey answers. What exactly does that analysis tell us about what these villagers are going through?
So principal component analysis, or PCA, is essentially a statistical tool used by researchers to take a massive, messy pile of data and find the biggest underlying trends.
Okay, so finding the main themes.
Exactly. It groups variables together to find the main characters of a problem, so to speak. And when they ran the numbers on these 200 households, they found that one massive factor accounted for almost 44% of the variance in how people experience these fires.
Wow, 44%.
Yeah. And they labeled this factor livelihoods, health, and environment.
Meaning the smoke isn't just an inconvenience, it's dominating their entire existence.
Precisely. I mean, when the researchers asked the villagers to rate the severity of these impacts on a scale of 1 to 5, physical and public health scored the highest at an average of 3.94.
That's incredibly high.
People are quite literally suffocating. We're talking about off-the-charts PM 2.5 air pollution.
I hear that term a lot, PM 2.5, especially during, like, wildfire season. But for anyone who doesn't know the exact mechanics of it, why is that specific type of pollution so dangerous to human health compared to just regular dust or smoke?
It basically comes down to size.
Yeah.
PM 2.5 refers to particulate matter that is 2.5 micrometers or smaller in diameter.
Which is tiny.
Very tiny. To put that in perspective, that is about 30 times smaller than the width of a single human hair.
Oh, wow.
Yeah, so because it is so microscopic, it doesn't just irritate your eyes or your throat. When you breathe it in, it bypasses all of your body's natural defenses in the nose and respiratory tract, goes deep into your lungs.
Wait, it goes past all the defenses?
Yep, it gets right past them and can actually cross over directly into your bloodstream.
Wow. So it's delivering toxic combustion byproducts straight to your organs.
Exactly. It triggers asthma, cardiovascular disease, and severe long-term respiratory issues. And this brings us to one of the most sobering statistics in the entire study.
Let's hear it.
So, the researchers looked at a specific subset of the villagers. They looked at the people who consistently try to protect themselves. We're talking about individuals who do everything right, you know?
Like wearing masks and staying inside.
Yes. They stay indoors, they wear masks, they seal their windows, all of it.
And what did the data say about them?
Even among that group of consistent protectors, 82% still reported suffering negative health impacts from the smoke.
That is wild. 82%.
It's staggering.
It proves that you cannot, life hack your way out of a systemic environmental collapse. If the air you breathe is toxic, personal responsibility only gets you so far.
Which is exactly why this requires a structural fix.
Okay, let's unpack this, because my immediate reaction, and I think the reaction of most outsiders looking at this, is usually, we'll just ban the fires, send in the police, make it illegal to burn the fields, and fine anyone who strikes a match.
Right, the typical enforcement approach.
Yeah, but the study pushes back on that heavily. Why doesn't a simple ban work?
Well, because a ban completely ignores the reality of why the fires are starting in the first place. Policymakers use a diagnostic tool called the DPSIR framework to map out complex environmental problems like this.
DPSIR.
Right. It stands for Drivers, Pressures, State, Impacts, and Responses. It's basically a causal chain. It helps you see the disease, not just the symptom.
So how does that chain map out for the farmers in Mae-hong-son?
Let's imagine a hypothetical local farmer. The driver for him is a desperate need for cash crops to survive, coupled with a very limited arable land in a mountainous region.
Okay, so he needs money but doesn't have much flat land to farm.
Exactly. That creates a pressure.
Yeah.
He has to clear whatever forest land he can access to plant his crops. But he can't afford heavy machinery, tractors, or paid labor.
But a match is free.
Exactly. Fire is free. So he burns the forest to clear it. But this leads to the state of the environment, which is off the charts: PM 2.5 pollution, lost biodiversity, and terribly degraded soil.
Because the fire destroys the soil quality.
Yeah, the fire burns away the organic matter in the topsoil, which then leads to the impacts. We already talked about the respiratory health impacts, but crucially, because the soil is now ruined, it yields fewer crops.
Which means our hypothetical farmer makes less money at harvest.
Right. He makes less money, but because his soil is dead, he now has to buy expensive, intense chemical fertilizers just to get a basic yield the next year.
So he's spending more to make less.
Yes. This traps him in a cycle of debt and poverty. And because he's poorer than ever next season, he has no choice but to use fire again to clear even more land to try and make up the difference.
Man.
It is a vicious, self-sustaining chemical fire feedback loop.
It sounds like telling these farmers don't burn is like telling a drowning person to just stop swallowing water. I mean, they aren't burning because they want to ruin the air. They're burning because it's their only economic lever.
Right, and this raises an important question.
Yeah.
How have governments typically responded to this?
Usually not well.
Historically, the response, the DPSI framework, has been resistance, building physical fire breaks, issuing strict time-bound burning bans, or outright prohibition.
But you are asking a farmer to choose between clean air for the province and feeding his own children.
That is a choice no one is going to make.
If it's between the air quality index and my family's dinner, I'm lighting the match every time. So since resistance and banning don't work, this study says we need an economic transition. The researchers bring up introducing the biocircular green economy model, or BCG.
Yes, the BCG model.
Can you break down what that actually means in a practical sense? Because BCG sounds like a lot of corporate buzzwords.
It does, but it's actually a very elegant framework when applied to agriculture. Bio means focusing on renewable biological resources, so using crops that naturally thrive in the local ecosystem.
Okay, that makes sense.
Circular means designing a system with zero waste, where the byproduct of one process becomes the raw material for another. And green means the overall system must actively restore ecological health rather than just extracting from it.
And according to the study, the ultimate crop to anchor this BCG transition in Mae-hong-son is industrial hemp, specifically a variety of cannabis sativa L that is bred to have very low THC, so we aren't talking about marijuana here.
No, not at all.
We're talking about the industrial fiber and seed crop. But why hemp? What makes it the magic bullet for this specific region?
What's fascinating here is how perfectly the biology of the hemp plant disrupts that chemical fire feedback loop we just talked about. First, hemp is incredibly fast-growing and produces a massive amount of biomass.
Okay.
As it grows, it drops leaves that decompose and return organic matter to the soil. It also has a deep taproot system.
Which means it reaches down and breaks up compacted soil, right?
Exactly. It aerates the soil and pulls up nutrients from deep below the surface. This is a process called phytoremediation.
Phytoremediation, got it.
Yeah, it actively regenerates the degraded soil that the fires ruined. Second, it requires far less water and fewer chemical pesticides than traditional cash crops. And third, Because of how it's cultivated and harvested, it does not require clearing massive tracts of new land with fire.
It's an economic fire extinguisher. It doesn't put out the flames with water, it puts out the need to start the fire in the first place.
That is a brilliant analogy. It shifts the entire region's approach from fighting fire's resistance to what this study calls living with fire resilience through livelihood transformation.
But here's the thing, it's great in theory that hemp saves the soil and clears the air. But if I'm a hypothetical farmer in MHS, I can't pay my grocery bill with phytoremediation.
No, you can't.
I can't eat carbon sequestration. We need to talk about how these villagers actually make money from this plant.
Absolutely. The transition only works if it's profitable. The study zeroes in on two specific communities making this transition, Banpangtong and Banmasakut.
And how are they doing?
The raw agricultural output they're seeing is impressive. They're yielding about 3,800 kilograms of fresh hemp stems per ray, alongside 280 kilograms of hemp seeds per ray.
And just for context, ray is the standard unit of land measurement in Thailand, roughly equal to 1,600 square meters.
Wait.
Okay, so a farmer harvests his field and ends up with a massive mountain of stems and seeds. What happens next? How does that become cash?
Well, the study outlines three main processing pathways, and they are incredibly diverse.
Let's walk through them. First, you have textiles and crafts.
Yes, and this relies heavily on the traditional generational knowledge of the local Econ ethnic group. The first step is taking those raw woody stems and putting them through a process called uniform decortication.
Which sounds incredibly technical. What is decortication, simply put?
Think of the hemp stem like a wire. You have the tough outer casing, which is the long, strong fiber, and you have the inner core, which is woody and brittle, called the hurd.
Okay, outer fiber and inner core.
Yeah. Decortication is the mechanical process of stripping that valuable outer fiber away from the inner woody core without damaging it.
Got it. Like stripping the plastic off a copper wire, but doing it to thousands of plant stalks?
Exactly. Once they extract that high-quality fiber, the camel weavers use their traditional techniques to turn it into premium fabrics, clothing, and intricate embroidery.
And is that actually profitable?
The value add is staggering. The study notes that processing the raw stem into fine hemp fiber can generate over 100,000 Thai baht per ray.
That is a massive leap in value from just selling a raw agricultural commodity. But they still have all those seeds left over. Which brings us to the second pathway, wellness and food.
Right. Those 280 kilograms of seeds are incredibly valuable. Hemp seeds are classified as a superfood.
Yeah, you see them in health food stores everywhere now.
Exactly. They are densely packed with plant-based protein and essential fatty acids like omega-3 and omega-6. By using cold press extraction, the communities pull the oil out of the seeds.
And they use that oil to create high-margin consumer products. We're talking soft gel, health supplements, protein powders, and massage oils. And I love the irony here.
That's that.
You have a plant that has been historically stigmatized and heavily policed for decades, and now it's being packaged as a premium, high-end spa product.
It is a remarkable rebranding.
Yeah.
But what makes this pathway truly unique to Mae Hong Son is that they aren't just making generic hemp oil.
Right, they're doing something special with it.
They are integrating traditional local herbal medicine recipes that have been in the region for centuries into these modern wellness products.
They are bottling ancient wisdom for the modern health market, which leads perfectly into the third pathway, which honestly surprised me, cultural tourism.
Yeah, that's a big one.
Because processing this crop isn't just about making physical goods, putting them in boxes, and shipping them to Bangkok. It's about bringing people to the province.
Exactly. The Hamel people use hemp deeply in their cultural rituals, their ceremonies, and their seasonal festivals.
Right.
So the policy framework suggests leveraging this by rebranding the entire Mae Hong Son province as a Thailand hemp-based wellness hub.
So instead of shipping the massage oil out, you bring the tourist in. They pay for the hotel, they eat at the local restaurants, they experience the traditional festivals, they see the weaving process firsthand, and then they buy the premium products directly at the source.
It creates a localized economic ecosystem.
Yeah.
But this is where we have to look closely at the study because there is a critical missing link that could make this entire framework collapse if it isn't handled correctly.
Here's where it gets really interesting, because I was just thinking about the logistics of this. How does a remote rural village actually manage all this?
It's a huge challenge.
How do we ensure the community actually keeps the wealth they are generating rather than some massive outside wellness conglomerate just swooping in, buying up the raw stems for pennies, and using the villagers as cheap labor?
You've just identified the classic trap of agricultural development.
Yeah.
In so many projects, The farmers take all the risk to grow the crop. They sell the raw material to a middleman, and 90% of the profit margin is made in a processing factory in a major city.
Exactly. So how do they stop that from happening here?
To prevent this, the study emphasizes the absolute necessity for government capital investment in district-level processing hubs.
Meaning the machines have to be owned and operated locally?
Yes. Decortication machines and commercial seed oil extractors are expensive. If the communities don't have their own processing hubs built in their districts, they remain entirely dependent on outside companies to do the refining.
And they lose all the profit margin.
Right. By building small-scale hubs directly in the community, the farmers can upgrade the value chain themselves. They strip their own fiber, they press their own oil, and because of that, they keep the premium profit margins inside the village economy.
Okay, so let's zoom out and look at the whole board. We have the miracle crop that stops the fires and heals the soil. We have the 3 processing pathways for textiles, wellness, and tourism.
Yep.
And we have the strategy to build local processing hubs to keep the wealth in the community. Sounds perfect, but let's look at the bottom line.
Numbers.
When the researchers actually ran the financial numbers on this policy, does it actually work? Because reading through the financial realities presented in the study was a bit of a roller coaster.
It is a complex financial picture, and this is where we really need to distinguish between traditional financial return on investment, or ROI, and something called social return on investment, or SROI.
Right, let's break that down. Looking at the micro level first, the study analyzed a small pilot community enterprise that was already doing this hemp processing.
And how did it do?
At that small scale, it was highly successful. They saw a 182% financial ROI. They had a gross margin of over 53,000 baht. For a small village co-op, that's a massive win.
It is a phenomenal micro-level success story. It proves the unit economics work. But the researchers then zoomed out and looked at the macro program level.
And that's where things change.
Right. They asked, what would it cost the government to scale this up across the entire province? When they factored in the roughly 5 million baht per year needed to train the farmers, build those district-level processing hubs, supply the machinery, and establish the market connections, the traditional financial ROI drops to a negative 98%.
So what does this all mean? Because I have to be honest, if I draft a business plan that requires millions of aid in capital, and I project a negative 98% return, and I take that to a bank,
They're going to say no.
they are going to laugh me out of the room. They might actually call security. How can policymakers possibly justify spending public money on a framework that loses almost all of its financial value on paper?
Well, if we connect this to the bigger picture, the justification becomes incredibly clear. And it highlights why the researchers stress that traditional financial accounting is fundamentally broken when it comes to evaluating public policy.
Because it's too narrow.
Yes. A standard bank balance sheet only measures cash in versus cash out. It completely fails to measure systemic public goods.
Because how do you put a price tag on breathable air?
Exactly. You cannot put a standard market price on preventing a hospital ward from overflowing with asthma patients. You can't put a simple price tag on the preservation of indigenous weaving knowledge or the ecological value of stopping a forest fire before it starts.
But the government is the one paying for those hospital visits and those firefighting helicopters anyway, so it is real money.
It is absolutely real money, which is why policy evaluations must use the SROI framework, social return on investment.
Okay, so how does SROI fix this?
SROI allows economists to monetize those social and environmental benefits and add them back into the ledger. For instance, the researchers calculated the reduced respiratory healthcare costs because the air is cleaner.
And what did that come out to?
That alone saves the public health system 19.67 million baht.
That is massive.
It is. Then they calculated the value of the avoided carbon emissions because the forests aren't burning, plus the immense boost to the local economy from the new cultural tourism we discussed.
And that adds up too.
Yeah, that adds another 21.3 million baht in value.
So when you take that scary negative 98% financial ROI, but you add all of those systemic savings and gains back into the equation, what happens to the math?
It completely flips. The final SROI ratio calculated in the study is 2.5 to 1.
Meaning for every baht the government invests in building these processing hubs and training these farmers, society gets 2.5 baht back in health, environmental, and economic value.
Precisely. It is a wildly successful intervention.
Yeah.
But you only see that success if you have the right tools to measure it. If you only look at the cost of a decortication machine versus the price of a bottle of hemp oil, you think the policy is a failure. But if you look at the entire ecosystem of human well-being, it is a triumph of public policy.
That is just incredible. It really changes how you look at the cost of solving problems.
It really does.
So let's bring this all together for you listening right now. We started this deep dive looking at a suffocating health and environmental crisis in northern Thailand, driven by the desperate poverty of a chemical fire feedback loop.
Right, the root cause.
We discovered an alternative, carbon-negative biocrop in industrial hemp that heals the soil without needing a match. We explored how localized, community-level processing of fibers and seed oils is the absolute secret to breaking the middleman trap and keeping wealth in the villages.
Exactly.
And finally, we proved that while it looks like a financial loss on a narrow spreadsheet, the social return on investment makes it an undeniable win for the region.
And I think the broader lesson here is about how we approach systemic problem solving in our own lives and industries. It's about realizing that sometimes, to solve a fire problem, you don't need water.
Yeah.
You don't need more resistance, more bans, or more strict regulations. Sometimes you just need an entirely different economic engine that makes the fire obsolete in the first place.
Which leaves us with one final thought to mull over as we wrap up. If an entire region can solve a devastating environmental crisis, improve their public health, and completely rebrand themselves as a premium wellness hub just by embracing a historically stigmatized, deeply misunderstood plant like hemp.
What else is out there?
Exactly. What other taboos or misunderstood resources in your own industry are just waiting for a second look? Could the very thing you currently consider your biggest nuisance actually be the exact economic fire extinguisher you've been looking for?
It's certainly a question worth asking.
Thanks for diving depth with us. We'll catch you next time.